Hello, welcome again. We are covering the subject thermodynamics for civil services main, IFS and various gate exam, and we have finished the topic first law of thermodynamics to non-flow or closed system. Now we will start the next chapter, that is first law applied to flow process. So in this the first topic is control volume. So here uh, we will discuss the two approaches to study the flow processes as well as the first law. Starting from the first law applied to a process or a system. So that is the first law applied to a system or to any process is Q is equal to del E plus S. Where Q is heat supplied and E is change in energy, all form of energy, can be internal energy, kinetic energy, potential energy. W is work. Okay. So now in the closed system we have neglected the change in kinetic energy, change in potential energy, because in the closed system there was no mass transfer, but here we are considering the open system, so there will be change in kinetic energy, there will be change in potential energy, and internal energy is also changing, will also change as it is changing in closed system. So this law now becomes like this. This we put the value of E as Ek plus Ep plus U is here, or del E is here, del Ek del Ep del U, where Ek is your kinetic energy, Ep is potential energy, U internal energy. So it will become Q del Ek plus del Ep plus del U is equal to W. So this is your suppose equation number 1, that is valid for the closed system also, because here we are taking change in kinetic energy into account. So it means there is some inflow and there is some outflow, that's why the energy will change. Okay. So, so when there is mass transfer across the system boundary, the system is called an open system, and that's why this kinetic energy and potential energy will change. Okay. So most of the devices that we consider in our practical application are your open system. So equation 1 refer to certain system having a particular mass of the substance, and it is free to move from one place to another place. Okay. So now if we consider this figure, this is your turbine, and some amount of fluid is entering here and running the turbine, and then it is leaving the one place. Okay. So now if we consider particular mass here and analyze this mass, it is going to this and going to this, going to this, and accounts work done in between the turbine, or if there is any heat transfer, then it is a Lagrangian approach. But if we consider this control surface, okay, then mass is entering here and mass is leaving here, in between we are getting this is your Euler's approach. Okay. So when we consider mass as moving system, so the mass will enter here and we concentrate on mass, it will run the turbine and will leave, then it is your Lagrangian approach. But if we consider a certain volume, this is shown by dotted line, then mass is entering here and mass is leaving here, and now we are concentrating on this particular volume. So that is your Euler's approach. So there are two approaches, one is Lagrangian approach, other is your Euler approach. Okay, so I am reading out this. Consider a steam turbine as shown in figure, in which steam enters at high pressure, does work upon the turbine rotor, and then leaves the turbine at low pressure through the exhaust pipe. If a certain mass of the system is considered as thermodynamic system, okay, and then the energy equation becomes same as this. Okay. Q is equal to del Ek plus del Ep plus del U plus del W. Okay. Okay, now that we have discussed, one is Lagrangian approach, another is Euler's approach. So these two paragraphs give the idea about this, or give a theory of this. In order to analyze the expansion process in turbine, the moving system is to be followed as it travels through the turbine, taking into account the work and heat interaction all the way through. This method is similar to that of Lagrange in fluid mechanics. Same that I explained, that is mass is entering here and we will analyze the mass, it will run the turbine and then leave, and so we will concentrate on mass. So that is your Lagrangian approach. And second approach is your Euler's approach. Although the point is, although the system approach is quite valid, there is another approach which is found to be highly convenient. Instead of concentrating attention on certain quantity of fluid which constitute a moving system in the flow process, attention is focused upon a fixed region in space called a control volume, though which moving substance flows, through which moving substance flows. This is similar to the analysis of Euler in fluid mechanics. So now we will concentrate on this particular volume. Some mass will enter here, some mass will leave here, and in between it will run the turbine. So some mass is entering in the control volume and mass is leaving the control volume. If these two masses are equal, then it is steady flow process. Okay. And so this is the control volume we are not considering mass. Okay. So that is your Euler's approach. In Lagrangian approach, we will concentrate on the same mass that has entered here, has done some work and left the turbine. Whereas in Euler's approach, we will concentrate on this volume. Mass is entering here, mass is leaving here, and turbine is producing work. Okay. So we will concentrate on this particular volume, not on this mass. So that is your Euler's approach. Okay. So when considering Euler's approach, the control volume and control surface is shown in figure. So this is your control volume and this is your control. This is your control volume, this is your control surface. The mass transfer takes place across the control surface. Section 1 and 2 allow mass transfer to take place, and Q and W are the heat and work interaction respectively. So here mass is entering, here mass is leaving, and Q and W are heat and work. So this is the first topic in the first law applied to flow process, that is control volume, with the two approaches, Lagrange approach and your Euler's approach, definition.